Well, this is the last video for Math 116. I'm going to go over the sample final exam, and that'll be it. All right, so we go back to the beginning of the term. We started out talking about functions. In problem 1, we've got a function f of x. That's 3x squared plus 1 over 2x. And first we want to find f of 5/6. So let's get our calculator out here. And so we'll do 3 times 5/6 squared plus 1. And then we want to divide that by 2 times 5/6. So this will be, let's see, so I'm getting, well, I'll turn that into a fraction, 2. So let's see here. I mean, I could just solve the problem, but I want to do this in pieces so that you can see if you make an error somewhere, kind of where that error is. So this is 37 over 12 in the numerator, and that was 3 and 1/12. And then in the denominator, that's going to be, what, 5/3. As a decimal, what is that, 1 2/3, right? Okay. So then we want to divide that, there we go, by 2 times 5/6. And that should do it, 1.85. Let's try this one. So if you're going to do this with decimals, all right, I think I've talked about this at some point. Type in a bunch of 3's because that's a repeating 3, right? We can put a bar over that and then divide that by 1.6 repeating, and there's our 1.85. Okay. Let's see here. Part B. F of 2x minus 1. So that's going to be 3 times 2x minus 1 squared plus 1 over 2 times 2x minus 1. So let's go ahead and square this out. 4x squared minus 4x plus 1. And then this will be 4x minus 2. So 12x squared minus 12x. This will be 3, but then that'll make it 4. And then over 4x minus 2. This you actually can reduce, right? So this is 2 times 6x squared minus 6x plus 2 over 2 times 2x minus 1. And so 6x squared minus 6x plus 2 over 2x minus 1. And that's lowest terms. We can't do anything more than that, unless we actually want to do that polynomial long division there, which usually not a whole lot of fun. Okay, let's see here. Problem 2 and 3 work off of g of x being 5x to the third plus 9x minus 7, and h of x being 4x minus 3 over x plus 2. Problem 2 says we want h on g of x. So that means we need to take the g function and plug it in wherever there's an x in the h function. So that's going to be 4 times 5x cubed plus 9x minus 7 minus 3. And then 5x cubed plus 9x minus 7 plus 2. So 20x to the third plus 36x minus 28, and then another minus 3 will be minus 31. 5x cubed plus 9x minus 5. The minus 7 and the plus 2 makes minus 5. And there's nothing more that we can really do with that. So we'll just leave it the way that it is. Problem 3. H inverse of x. Okay, so first I'll write this y equals 4x minus 3 over x plus 2. And then I'll swap the variables. X equals 4y minus 3 over y plus 2. And now we're going to get the y by itself. So let's clear out the denominator. And those cancel. This will be xy plus 2x equals 4y minus 3. Let's see here. I'll add the 3 over to this side and subtract the xy over here. The idea is we want to collect anything that still has a y in it. We want to get those things together. Over here we'll have 2x plus 3 equals 4y minus xy. And then remember, the trick to getting that y by itself is to factor it out, y times 4 minus x, and then divide on both sides by 4 minus x. So y, which is h inverse, will be 2x plus 3 over 4 minus x. Now, if you collect things on the opposite sides from what I did, then you would end up with another expression which is also correct, negative 2x minus 3 over x minus 4. It's the same fraction, it's just been multiplied by negative 1 over negative 1. So this is correct, and this is correct as well. All right, so that's problem 3. Problem 4 is one of these transformation problems, so let me make some space to draw that. Okay. Now, our function here is negative 7, negative 2, negative 5, 5, and then 0, 0. So that is how it starts. 3, 2, and 7, 2. Okay. Oops. Off there. There we go. And then like that. Okay, so that's our function f of x. And we want 1/2 f of x minus 5. Okay? Alright, so if you look at these transformations, both of these affect the y variables, okay? Anything that affects the x variable happens inside the parentheses and nothing is going on in there. So this is our x coordinates are going to stay the same, our y coordinates are going to get cut in half and then move down 5 places. So this negative 2 becomes negative 1 minus 5 is negative 6. Okay, so I'll make a little table here for these x and y values. What was that? Negative 5, 5, 0, 0, 3, 2, and 7, 2. All right, over here, 1/2 f of x minus 5, negative 6. And then the next one, negative 5, 5. So that'll be 2.5 minus 5 is negative 2.5. So negative 5, negative 2.5. 0, 0, let's see here, goes to half of 0 is still 0, so that'll just go down to negative 5. 3, 2. The 2 gets cut in half to 1. And then 1 minus 5 is negative 4, so that'll be 3, negative 4, like that. And then the 7 will also go to negative 4 as well. And so there's our transformed function for problem 4. All right, problem 5 is a piecewise defined function. Let's take a look at that one. Gets pretty messy as I'm writing on it. I don't get chalk dust, but I do get this chemical dust. All right, so first I'll write down the function. Number 5, y is negative x squared minus 13x minus 40 between negative 8 and negative 4, and then 5/4 x plus 3 from negative 4 to 0 inclusive, and then negative 2/3 x minus 3 for x greater than 0. All right. So, first off, from negative 8 to negative 4, I'm just going to take negative 8 and I'm going to plug it in here and see what we get. Be careful because you've got negative 8 squared, and so that's going to be negative positive 64. Minus 13 times negative 8 minus 40. So let's see here. Negative 64. Plus 13 times 8 minus 40 is 0. Let's see here. Oh yeah, because this is negative 8 times 5. So 8 times 5 is 40, 8 and 5 make 13, and so negative 8 is one of the roots of that. And I think the other one will be at negative 5. And there's nothing wrong with graphing this and looking at the parabola between negative 8 and negative 4. The other thing you can do, besides looking at it on the graph, is you can look at it in the table. So let's see here. Negative x squared minus 13x minus 40. So let's take a look at this on the graphing calculator here. So there's the function itself. Now if you hit graph, we'll see the parabola. So that's the part that I want to see. And the other thing you can do is you can go hit second graph and go into the table. Oh, my table is a little messed up. I got to fix it. I got to put it back to the counting by ones instead of counting by fives. So there we go. Second graph is table, and so out at negative 8 there's 0, negative 7 is 2, negative 6 is 2, negative 5 is 0, negative 4 is negative 4. So there's all those points for me to graph. I could have just calculated them the way that I did the first one, but little variety is the spice of life here. So let's see here. So that's going to be 2, 2. And then this negative 4 point gets an open circle, right? Because we don't know whether the actual function value is going to be there at negative 4 or whether this is going to give us some other value. Now these linear functions are a lot easier to graph. You can put them on the graphing calculator as well, but you don't really need to. 5/4 times negative 4 plus 3, so that's negative 5 plus 3, which is negative 2. So yeah, so the function value is actually right here at negative 4. And then at 0, we've got a y-intercept of positive 3. And let's see here. Yeah, so this is just going to kind of cut through there like that. Okay, so that's from -4 to 0, 5/4 x plus 3. And then the next one, this one has a y-intercept at -3, so that gets an open circle, right, because there's no equals to here. This is where the function picks up its value for 0, for x equals 0. So that's an open circle. It's kind of hard to see. There we go. And then our slope here is -2/3. So I'll go down 2 and over 3, and then we can do that one more time. And there's our line right there. I'll put an arrow on it because it keeps going, whereas this one just stops at -8. So there's our function, piecewise defined. Okay. Problem 6 is one of these optimization problems from the end of chapter 1. And we had, I gave you a choice of 2 out of 4 on the midterm. On this one, we're just going to do one of these, what do you call it, analytic geometry optimization problems. Okay, so in problem 6, we've got our distance formula for the coordinate system here. And so we've got a graph of y equals 2x cubed minus 5x squared plus 3. Looks something like this. We want to know what point on here, xy, is closest to the point 1, 4. It could be there. It might be over here. We might see one of those double bottoms on when we graph that distance formula. But in any event, let's go ahead and set it up first. So our distance here is going to be the square root of x minus 1 all squared plus y minus 4 all squared. And then, so we can graph this and also express it as a function of x. We're going to replace that y with 2x cubed minus 5x squared plus 3 minus 4. You can leave it like that if you'd like. I don't recommend squaring these out, but I think it is often helpful just to do a little quick addition or subtraction, combining like terms inside that y parentheses. So there's our d of x function. Let's see, so that's part A. And then now we want to find a point on the graph that is closest. So we graph that square root x minus 1 all squared plus 2x cubed minus 5x squared minus 1 all squared. And so now we'll look at that graph. I'll put a little sketch of it up here. And yeah, we do have this double, or the W look. Let me find each one of those and see which one is closest. I think it's going to be the one that's right here. But let's see. Where is that? X is 0.0923. And our D there is 1.381. Now this one over here, let's see what that is. 2.567. And what's our D there? 1.571. Yeah, so this one is closest. All right, so there's part A. In part B, we know that the x is going to be about 0.0923. Let's see, did I ask you to round 3 decimal places? So 0.92. I'll keep the 3 on there when I plug it back in so that I can get it as accurate as possible for the y. So let's see here, 0.0923. I'm going to store that as x and then evaluate 2x to the third minus 5x squared plus 3. And so that comes out to be y should be approximately 2.959 to 3 decimal places. Okay, and then part C, we've already got the distance there. D is about 1.381. And there we go. There's our distance function, there's the point that's closest, and there's how close it is. Okay, now we get to the second half of the term. Topics that we've talked about in chapters 2, 3, and 4. I think the first question on here is a circle question. Yeah. And I've got the standard form for the equation of a circle on here. X minus h all squared plus y minus k all squared equals r squared. And we want to take this x squared minus x plus y squared plus 2y plus 5 equals 17 and express it in standard form. Okay, so I usually like to clear out any constants over here and then leave a space to complete the square. Oops, didn't leave a space there. There we go. 12. All right, so for the x here, this is going to be x minus a half all squared. So to complete that square, we're going to need to add a fourth on. And this one will be y plus 1 all squared. And to complete that square, we're going to need to add 1 onto both sides. Okay, so this will be 13.25. So there's standard form. And then we want to know what's the center and what's the radius. Okay, so the center of the circle is the point 1/2, -1. And our radius is whatever the square root of 13.25 is. Let's see if we can get a good approximation for that. 3.64. Okay. Now there's problem 7. Let's see. Problem 8 is about parabolas. Okay, let's see here. Problem 8. So, got a standard form equation here. You know there are other possibilities depending on how the parabola is oriented, but this one is either going to be up or down because the x is being squared. Or, yeah, and in the problem we can see that the x is being squared. Plus x squared minus 6x equals 0. Okay, so I'm going to leave the x squared where it is and move the 6y and the 9 to the other side. So those cancel out. X squared minus 6x is negative 6y plus 9. So we cut this in half. X minus 3 squared. And then we'll need a 3 squared to complete this, plus 9 and plus 9. So this is now x minus 3 all squared. This is minus 6y plus 18. And so to finish this off, we want to factor out whatever the coefficient of the y is. Notice when I factor out a negative, this sign changes from plus to minus. Okay? So the vertex for this parabola is where x is 3 and y is 3. Let's see. Our focus, this is a negative parabola, so it's upside down. Okay? 4p is equal to 6 or negative 6, depending on how you want to think of it. So the focal distance is going to be 1.5. So the focus is going to be 1.5 places below the vertex. The x-coordinate stays the same. The y-coordinate we subtract 1.5 from. And then the directrix is going to be the line that's 1.5 above the vertex. So that's going to be the horizontal line y equals 4.5. And there we go. Vertex, focus, directrix, and equation in standard form. All right. Problem 9 is one of those application problems for the parabola. And remember, we can work from a simplified version of that standard equation if we put the vertex at the origin. And so, let's see here. Paraboloid mirror is used to concentrate the sun's rays and create a heat source. Mirror is 20 feet across. Okay, so this is 20 feet, which means that this is 10, and that's negative 10. 6 feet deep, so that says this is the point 10, 6, because that distance is 6 feet. Where will the heat be concentrated? At the focus. Okay, so we need to find out what's the value of P. So, our simplified equation here is x squared equals 4py. And let's take the point 10, 6 and plug it in there. So 100 is 24p. And then we'll divide on both sides by 24. So p is going to be, this is going to be 25 over 6, 4 1/6, 4 feet, 2 inches. You can just say 4 1/6 feet above the base. Okay? All right. Now we get the last 3 questions from Chapter 3 and Chapter 4. So, first from Chapter 3 we have a sequence. We want a general expression, a sub n, for the nth term of this 1, 3/2, 9/3, 27 over 4, 81 over 5, 243 over 6. I'll stop there. I put more on the test paper so that you could see more clearly. My hope was the pattern. Okay? So the top, the numerator, these are powers of 3. You can think of this as 3 to the 0 power over 1. Okay? And so on. Okay? So, a sub n, the first term, we always start with a sub 1 here. I remember on the quizzes that some people were kind of assuming that we were starting with an a sub 0 term, but that's really not common. We typically start with a sub 1. So, the first term is going to be 3 to the n minus 1 on top and n on the bottom. And I think that's it. The second term is going to be 3 to the first over 2, 3 squared over 3, and there we go. 3 to the n minus 1 over n. All right, problem 11 is very similar to problem 10, except we're going to use the sigma notation. Okay, we've got a finite series, so it does end. So I guess I'll have to write out all of the terms here. There we go. So first of all, notice that it's an alternating series. It alternates back and forth between plus and minus. So here you have a choice. You can start your index at 1 or you can start it at 0, whichever you'd prefer to do. I'm going to start mine at 1. Let's see. Then we'll have negative 1 to the I plus 1 or I minus 1. Either way, right? Because if it's plus 1, it'll make it 2, which is positive. Negative 1 to the second is positive. If it's minus 1, that'll make it 0 power. Negative 1 to the 0 power is positive 1. So that works out just fine. And then the fraction is going to be 1 over, I think, n squared is about it, right? Because it's 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, and then we end at 7. Now we can put this up in the numerator if you want. That'll clean it up a little bit. So I from 1 to 7, negative 1 to the I plus 1 over I squared. There I go again, using n instead of I. There we go. Okay, so there's problem 11. We've got one more to look at. Problem 12. We've got 100 tickets sold to 100 different people for a drawing for 4 distinct prizes. That's the key to this problem. It's because the prizes are distinct, this is a permutation. Okay? So the order that they're awarded does matter, right? If you have ticket number 34, ticket number 99, ticket number 5, and ticket number 12, that's a different result from 12 winning the grand prize. Well, yeah, first, second, third, and fourth. Okay? So, these are 2 distinct possibilities. Even though the same 4 people end up winning, they end up winning different prizes. So what I'm saying is that's why this is a permutation. Okay, so in part A, how many ways are there to award the prizes? 100 P4. You can also calculate it like this. It does exactly the same thing. There's nothing wrong with either one. And you can leave your answer as 100 P4 if you want to. Let's see what that turns out to be. 100 P4, 94 million or so. 109,400. Okay, so that's part A. Now part B says, how many ways are there to award the prizes if the person holding ticket 47 wins the grand prize? So this says person holding ticket 47 is going to win that grand prize. There's only one way for that to happen. Okay? Now there's 99 other people. And then, so we want to distribute them into the other 3 prizes. So the answer for part B is going to be 99P3, which turns out to be 941,094, 941,000 or so. It's this divided by 100, essentially, because you're missing that right there. Okay? Okay, so that's it for the final. As always, if you have any questions about any of this, please let me know, and we will see you next week.